All right, so it's like 2 minutes after 5 my time, 9 PST, I think. So I think we should start. What we have for today is it's another demo. This time it will be Stacky by Joe Kaiser, and the next agenda item I think is very interesting is how to expose your workloads to the outside, to the external world. Looks like there's too many options probably. So I hope it will be interesting discussion of what people are doing actually. So Joe is with us. So Joe, can you please proceed with the demo?
Sure. Let's see. Is there an option here to
Yeah, you should be able to share.
Is that the whole screen?
Okay, yeah, we can see it now.
Okay. Is that level of is that resolution high enough so that people can see?
It's very nice view from sitting.
It's sky high.
Yeah, it's very nice.
It's too high?
No, it's okay. I think it's okay.
Because I can make it bigger, I can make it smaller. Because if it's too small.
I think it's perfect actually.
Okay, all right, we'll go with it. Okay, so I have very few slides. Really just want to tell you what I'm about to show you, and then we're going to show you. So I'm with a company called StackIQ. We have an open source, our open source installer is called Stacky. We open sourced it about a year and a half ago, and it has been the basis for the installation of a fair number of enterprises. It was based on the ROX project, if any of you are familiar, out of UCSD. We have two of the original developers of that project. And we use it to install just about everything at this point. What it does, it installs mostly bare metal. We do VMs. We have one client who uses it to install not only their bare metal machines, but also a fairly large number of their VMware machines as well. It's Kickstart based. It's not image based. We do parallel formatting of disk, which is unique in the in terms of the installers, right? So this is just your basic TFTP, DCP, Pixie stuff. Grab a Kickstart and install a machine. You know, the partitions, the RPM software packages, all the post-installation scripts. It's the same stuff that you have probably done at some point in your career with regard to getting a group of machines up to a functional level that is consistent, right? The things that we do that are different are the parallel formatting of disk, and I need to qualify this simply because we don't do parallel formatting disk in Stacky 3.2 for 7.x versions of CentOS and Red Hat. That will change with the next release, which should be out in about 3 or 4 weeks. And it's one of the big differences between us. It doesn't matter so much since CentOS ran to XFS, but we had a guy on our Slack list ask about, you know, why is the formatting of a 48 drive machine that has 6 terabyte drives for each of those 48 drives taking so long? And that was why. It was something that we had missed in that particular rev. So we also do parallel sharing of RPMs during the installation. This makes it so that it's a peer-to-peer BitTorrent-like, although we've stripped out a lot of the stuff so that it works faster on a closed network, and all that stuff gets installed at the same time. Right now we're CentOS Red Hat based. The Pro version has Ubuntu and SLES in it, but I am pushing hard to get Ubuntu into the open source version with the next release. And if I can do that, that will open the door. And the next release also in Stacky 4.0 makes it a lot easier to roll in additional OSs and use their native language for installing machines. So CoreOS and Rancher OS and Alpine are sorts of things that I'd really want to start looking at. We do networking, multiple subnets, VLANing, bonding, all that is definable in a spreadsheet. And before you laugh about spreadsheets, a lot of the people that we deal with think it's a revelation to be able to define their partition schemes and their controller schemes by spreadsheet. So I know it's really old school and it's not YAML or any of the other egregious sorts of configuration languages out there, but it works. Controller config as well. We talked to the controller configuration. The controller configuration is able to set up your controller configs from the installation so that you never have to touch the keyboard and monitor ever install them ever again. So we cover the LSI and HP controllers, and we catch most of them with that support. So basically with Stacky, it allows you to do whatever you can do with Linux, except on a whole bunch of machines all at once. And our goal is to make it fast. So the difference between installing 5 machines and 500 machines for us is fairly minimal in terms of time. We have one user who installs their Hadoop infrastructure uses Stacky to install the base OS and partition all their disks and drives, and then does an Ansible run to set up their Hadoop configuration. And that takes them 14 minutes on 280 machines, so it's pretty fast. So Stacky and Kubernetes and Docker, really, it's all three, because I haven't explored Rocket yet. So one of the things about being the director of open source engineering, it means that I get to play with real cool stuff and make it available as an application stack. So we take care of the bare metal, but you can layer applications on top of that if you want. A lot of people simply just install the bare metal and then they run their DevOps tools, Puppet, Salt, Ansible, whatever. But we have this notion of a palette. I inherited this metaphor for Stacky, which is the data warehouse. So you add configuration with carts and with palettes, and we'll get into a little bit of that in here in a little bit. So what this is going to be is it's going to be a bare metal installation of Kubernetes with Docker. This version is not the one that is currently available on the GitHub site. That was our base phase 1 version, which means it just gets it up, gets it working, it'll function. And this version that I'm about to show you today has TLS certificates everywhere and a little more lockdown than the first one. It's using etcd and FlannelD. We're doing 3-node for etcd. We're not doing storage backend on that. I haven't dealt with storage in any of this yet. CentOS 7.3 on the back end, except there's a 4.10 kernel that will be installed, and I'll tell you why I did that was because I wanted to use the overlay FS, because if you start looking at the documentation for CentOS, they say, don't use the device mapper because it's horrible performance. Like, okay, cool, I'll use the overlay FS, and in 7.3 and 7.2, that's listed as preview software. So I stole a kernel from 4.10, and that seems to be working fine. All nodes are on a private subnet, and I'm accessing the public subnet through and I'm accessing the public access through the front end. You could put all of them with a public IP if you want to do that, but I don't think that's advisable. As soon as I can figure out how to mirror a Docker registry rationally, it's very likely that we'll make it so that there's a localized Docker registry that you can pull these things from. Prior to that, in phase 1, I was pushing tar images into a private Docker registry, and long term, I don't think that's sustainable. And so some of the caveats, I'm still pretty new at Kubernetes. I don't understand all the questions, and I certainly don't even understand all the answers yet. So there are going to be 3 required palettes, and we'll talk about those, and then we're going to do the customization through some spreadsheets, and then we're going to install them, and it'll be incredibly, incredibly awesome. And I will address phase 1, phase 2, and phase 3 at the end of this. So we are going to start off with a how How much time do I have, Tomas?
I'm not sure. Well, we have a 15 minutes planned, but
Okay.
you can use 30 minutes. It's not a problem.
Okay. If anybody wants me to go back to show the installation of a front end, I will. So what I have here is Stacky Cube, and it is my management server, my front end. So I have pre-installed this one because I didn't know really how much time I would have here. Typically, I will do do this like a cooking demonstration. I'll start the installation of a Stacky management server, and then cut to a running server. So pretend that I did the actual demo of the start of the Stacky front end, and now we're cutting to a running server. Let me just say two things about the Stacky front end. You can either use the minimal ISO that we have to install both the Stacky software and a minimal CentOS 7 OS, and then do everything, make your adaptations from there. Or you can start with a CentOS vanilla server, and you can add the Stacky palette on top of that with a script that comes on that ISO, okay? So there are two ways to do that. They're in greater detail on the stacky.com site and on the GitHub at stackiq.com. So what we have here is I have a set of palettes. So when you first install a machine, this is what you get. You get the Stacky palette and the OS palette. The Stacky palette has all the software that makes all of this run, so you need that. The OS is a minimal OS, so you need that as well. And we have a front end. We have one host. We have the front end. That's it. And everything else now we want to install. There are a couple of ways to install. We can do discovery, which is where you set the front end into promiscuous DHCP mode. So we'll show you how you start that. And we're going to set the appliance type as backend. We have this notion of appliances that are essentially just logical I don't want to say containers, logical constructs for holding configuration for your machines. So we have some people so Salesforce uses appliances as roles. So the role that they play within their infrastructure is how they get defined as an appliance, and that appliance then has specific configuration that goes with it. That configuration at American Express is based solely on the hardware profile of a given machine. So if a given machine has 5 disks and in a RAID 5, they call that an edge node, and that's what they install it as an appliance. So there are a couple of ways to take care of that. So where are we at? So let me show you how briefly. We'll power one on this way, and then we'll install the rest with a spreadsheet. So while this is powering up, I just want to let you know that what I have here on the Utah data center is I have a bunch of, I have 5 Dell R320s running in the background. You should be able to hear that first one. And since I'm so lazy that I can't stand getting up and walking 12 feet to, yeah, you gotta hear when all 5 of them go off. The thing that I can't stand is walking 12 feet to actually push a button. So I've made it so that I have wired IPMI and Wake on LAN into those machines. So I do serial console over LAN and serial and power over LAN from a Raspberry Pi, which acts as the DMZ server. So when I'm remote, I can do demos as well. The Raspberry Pi also acts as my serial console concentrator, so we can actually see what's going on during an installation. So this should get discovered here shortly once we start seeing it. And what it's going to do is going to go through the DCP, PXE, TFTP, all that kind of stuff. and it's just going to install this basic OS for me. And typically when people are actually using this tool, what I tell them to do is the way to get a hold of your infrastructure is to start with the very base, right? Make it so that you don't layer anything on top until you have had some experience with doing this. So you install one back-end machine. Here we go, we're discovered. And we're going to wait till there's a little star here, which will tell us when that's kick-started, which it's starting to kickstart. So you install one back-end machine. And if you're happy with it, then you install all of them so that you can get them under your control. Once they're under the control in the front end, now you can start adapting them. The cost of reinstalling is fairly minimal in terms of time. So it's okay to kind of treat them as disposable, which is what they are. You should boot them up and get them going. So once this kickstarts, we're going to start customizing our back end. We're going to add some more hosts. We're going to also set up the software, and then we're going to reinstall all of these. And then while we're reinstalling all of them, which takes about 20 minutes for Kubernetes, we'll do the we'll do some other, we'll take some questions. Okay, so the star says it's kickstarted, so I can stop out of this. And you'll see now I have this back-end host. And what it's done is it's recorded my interface, my interfaces. So this machine actually has two interfaces. It has one on the private net. So I have two networks here, one private, one public. I actually don't plumb the public on the back end nodes. I've plumbed it on the front end node so I can get out. And but it will discover everything that's on here. These machines have InfiniBand on them. When I plug that in, all the InfiniBand interfaces also get discovered. And what that allows me to do is that after the fact, if I decide that I'm going to add a network, I can add the network and I can add the IP addressing scheme to the database and resync the network config for the backend node without doing a reinstall, and we'll automatically get that network up and functioning. Okay, so here we go. We're partitioning here on the left on backend 0, and now we're starting to install the RPMs. It's not going to do any RPM sharing because there's no machine there that's other than the front end that's doing it. So let's get Kubernetes up. So I have these pallets. And I want something more for Kubernetes. For one, I need all the CentOS 7 because I don't know all the RPM dependencies. I want everything there if I need to pull it. So I have a stacky CentOS updates, which I also need because I want whatever's recent. This actually can be created with a command called stack create mirror, which if you give it a repo ID or a URL, will pull down RPMs and turn them into an ISO. Pallets are essentially ISO files that contain configuration or software or both. So, but in the instance of CentOS and CentOS 7, it's just a bunch of RPMs. For Stacky Docker, Kubernetes, and Prometheus, these are available on the GitHub. The most current version should be available in the next week, promise, with documentation, which is actually the stumbling point right now. And these contain both RPMs, so like Stacky Kubernetes has the kernel RPMs that I pulled for the more advanced kernel, but it also has configuration that sets it up. So what we're going to do is we're going to add these. We're going to add all these pallets, and then they're going to be stuck on our front end. CentOS is big, so it'll take a little while. The next version of Stacky is actually going to get away from ISOs as pallets, so you should be able to add arbitrary sets of directories with packages or software. So it should be a little easier. I haven't done a preview of that myself yet, so it should be interesting to see how it goes. Okay, so where are we? So we're doing pallets. We've got an installation going. We want to do cube demo. Oh, I was going to talk about another way to customize. So the typical way to customize your particular set of things is with a cart. So pallets are kind of advanced to build, and generally they'll come from us or they'll come from people in the community who have experience building with them. But you can set yours with you can create yours with a cart. So we're going to add a cart. Add or create, and we're going to call it site custom. Okay, we have a site custom cart, and it's not currently enabled anywhere, and there are two directories that matter. So the RPMs directory here, that matters because if there are particular RPMs that you want that are not available in any of the pallets that you've loaded, then you can add them here and they'll be available during installation to all the machines. So the other one is the nodes directory. So this is going to freak everybody out because it always does, because it says XML at the end. But let me show you what we're going to do here. So we've created a kickstart generator. What it does is it takes a bunch of snippets of configuration and turns them into one great big kickstart file. That kickstart file, if you're not familiar with Kickstart, essentially just maps to the installation code when you make a request to install a CentOS or Red Hat box. It's just a big shell script with special sections. Our special sections get mapped in HTML tags. So there's a post section, there's a main section, there's a pre section, and we use tags to map to those particular things. So if you have something that belongs there, you can add it. So I'm actually have a cart from a previous install, and I'm going to import that here. But I don't want to, so we'll take rid of that. I have an extra kickstart there. Okay, so here I'm going to go through it. So this is what I typically customize some of my front ends to do on my back end nodes. So I always put LSOF on because I can't stand not knowing who's doing what. SOCAT's almost always on because I never know when I do weird networking things. I want to disable, so a package tag will essentially just take the package and put it in the package section of Kickstart. If I disable a section with disable equals 1, what will happen is you'll get the minus sign. So I'm removing all the wireless stuff. I don't need wireless on these machines. They don't have wireless. The IVTV, have no idea why that gets installed as a part of the CentOS base, but it does. And then I'm making sure that core, which is part of a group, is going to be installed as well by putting a tag called meta. So package tags can have other things within them. Post tags can as well. So in this post tag here, so this will run during the post section. What I'm doing is I'm going to put these two things into sysctl.conf, and mode is going to be equal to append. And what that does is that this turns on the ARP tables and the IP tables that keep showing me an error whenever I install Kubernetes. So I'm getting rid of that. All right, so that's the way to site customize. We want to enable this. Let's see. So we've just enabled this. So if I list my box, so our metaphor is a little backwards. So carts and pallets go into boxes instead of boxes being on carts or in carts or on pallets. Don't ask me. I didn't think it up. Okay, so here we go. We've got some pallets. And they're not enabled until you enable. Our goal is to say, let you shoot yourself in your foot on your own. So we give you as much latitude as possible. So in particular, what I want to do is I want to enable CentOS updates, Docker, Kubernetes, and Prometheus all for my default box. So we'll do that. Okay, but I don't want the minimal OS because it'll conflict with CentOS, so I'm going to disable it. Okay, so I have one machine. I have a bunch of things that are enabled. What we want to do is we want to get the whole thing going. So we're going to load some hosts from our from a spreadsheet. Backend 00 is already here. I could have discovered all of these as well and could have then just done the setup of the attributes in the storage partitions. But here I'm going to just go ahead and load all of these. You'll be amazed, I'm sure some of you are like, CSV. I actually get that quite a lot. And when we thought it was a little crazy too, until we met a significant number of people in industry who that's the way they manage their stuff. They set it out, they get all the data that they need from it before they install anything at all. So this is one way that we decided it was the best way to do it. Exactly. So now I have a bunch of hosts. Cool. So now let's set some things up. So let's see. We want partitions. By default, partitions will be a /16 gig, a /var 20 gig, a swap of 8192, and everything else will go on a particular partition called state partition 1. That's the default. So I actually want to have my own partitions for this. In particular, I want to put varlib docker on an overlay fs. So we're going to load this in. Okay, and what this means is that any back-end machine will get this as its configuration. You can set this at a global level. You can set this at a host level as well.
So, Joe, sorry for interrupting. So, how much time do we need? Because we're like 30 minutes already.
Okay. We have 30. Yeah, let me finish this and start the install, and then we can go discuss other things, and hopefully this will be installed by the time we're done.
Okay. All right. Okay, cool.
All right. Okay, so we're going to add some attribute files because there are some. In order for the Kubernetes files to work, it requires that some attributes get set. Attributes are key value pairs that are used in the kickstart so that you can set things dynamically, which means you only have to have one kickstart file, not a bunch for a bunch of different files. So we're going to do that. We're also going to set up a Kube network on the 172. There's an issue with the way that we handled attributes that look like that in a spreadsheet. We also have to run some things with the palette. So the palettes themselves might have server configuration on the front that we have to run. In particular, I know that Stacky Kubernetes does because I wrote it. So we're going to run that. And Prometheus does also. Stacky Docker also has some stuff for the front end, but you only need it if you're going to run the Stacky Docker palette on its own without Kubernetes. Prometheus is going to set up on this particular front end. Typically, I don't do that, but I wanted to be able to get a sense of what kind of monitoring was available out there. Okay, so I think we have everything added. So what we're going to do is we're going to reinstall these machines. So when you first install machines, they are set to boot from local disk. That's what this OS flag means. We want to install them. So we're going to set their flag to install. And then we're going to set an attribute called nuke disks for the backend nodes. And what this is going to do is it's going to rewrite the partition formatting that are on these nodes. And I'll tell you why we do that as soon as I power these, cycle these. Okay, so the reason why we set nuke disks when you first install a set of machines that you added with partition is we don't want to do anything to your machines until you're ready to do it. Nuke disks will redo the partitioning. There's also a concomitant controller attribute called nuke controller that will reset your controller configuration and put it into the configuration you expect. What that does, it sets you to a known state. Every reinstall after that will not reformat disks unless you particularly throw the nuke disks flag. What that means is that if you have machines with large numbers of disk and you want to hang on to the data that's on them, we're not going to reinstall it on a reinstall. We won't reformat that on a reinstall unless you specifically request it. So in this instance, we make it so that you have to physically find your foot in order to be able to, shoot your toe off. So what these machines are going to do is they're going to install. They will get they'll get the Docker, Kubernetes, and Prometheus configuration that they need to have. And when they come up, we should be able to get the Kubernetes dashboard, and we should be able to look at the Grafana, what do you call those things? Grafana graphs. We're going to install Firefox and make that a little easier. Okay, so we're going to let this go, and I'll answer questions in between. And we can actually move on to the other one as well, and you can just keep an eye on it when this comes back. So let me finish up here. So there are phase 1, phase 2, and phase 3. Phase 1 is currently on GitHub. This is phase 2, so that it's secure with a minimal needed for a production set of machines. This does not include kubedns. I don't know if anybody has seen my questions on the list the past few days. I was like, has anybody set up kubedns on bare metal? And people were like, why would you want to do that? And after thinking about that, I'm not really sure I do want to do that because it's not currently functioning. Next, phase 3 is going to be CoreOS as an option. You can do that from the same front end. Disk integration, I haven't done anything with disk. I'd like to do Calico and Weave, figure out the private registry thing, and rock it. It may be that in the later stages of this, that what we see, if kubeadm turns out to be a viable candidate for actual production installations, I may just move to that way because I think people are more familiar or getting familiar with the idea of running the services as containers. and that might be something people want. I don't think it's production yet, so I'm not really willing to go far down that. I know of one company here that's used KubeADM for their production, and they're having problems with it. So if it's alpha, I'm not going to touch it. If it's beta, I'll consider it. And again, I don't know enough to be able to make the best decisions, so that's a big part of the reason why I joined SIG On-Prem and looking at the Slack channel, and it's been really helpful. So Tomas, if you want to just go ahead and go on to the next. So phase 2, let me answer this one question. Phase 2 is going to be available any day now. And if there aren't any more questions, I'll turn back over to Tomas. We can go on to the next thing and hop back when these machines are actually installed.
All right, thank you. Yeah, if we run out of time, we can just take it offline or to the mailing list. We have a couple of questions captured in the documents, so there will be.
Do you want me to continue to share my screen, or do you want control?
Well, we can keep it there.
Okay.
Yeah. So thanks for the demo again, and let's proceed to the second agenda item, which is essentially how people expose their workloads to the outside world, and pros and cons on different methods. So I think again, it's we have a situation when there are some standards defined if you run on cloud environment like GKE or AWS, but on-prem. I haven't seen like a document with best practices or what works for the people, what's the best. So yeah, I think it can be interesting to discuss it here, how people do it on premise. So there are several options, and I think the first one, service type load balancer. So it works on cloud providers, but I'm essentially I'm not sure what's the status of this on premise. Is there any controller that can actually act as a load balancer for service?
No.
No, there is none. There's only this service load balancer, which is not like the object type, right?
Mm-hmm. But is there any integration between the service when you use load balancer type and this load balancer controller or whatever it is?
Not at all.
Ingress chart on Dalton. All right. So if
I saw when we were talking.
Yeah. So if this like the most common method on cloud providers doesn't work on-premise, so what you guys are using actually? I know that Marco Ceppi provided some answers. So Jorge, can you describe how you guys do it with Juju-based installer?
Yeah, I'm actually grabbing Marco for this conversation now, so if you can give me a minute.
Okay.
We can talk about the tectonic setup if you like.
All right, yeah. Cool. Yeah, sure.
Yeah, so when we were building the tectonic ingress setups for AWS and for bare metal, we explored this a lot. And I guess there are a lot of pitfalls actually concerned around ingress and how you do it. Where to begin? We used the Nginx ingress controller. We explored the traffic one for a while. We sort of settled on run an ingress yourself rather than, like you said, there is no load balancer type equivalent on bare metal, and I don't know that one even really makes sense necessarily. Among when users are setting up that cluster, they have two options. You can use, well, they will have two options soon. Using host port binding, you can run an ingress controller, bind to host ports on particular nodes, and that's sort of the easy path for setup because it means people just need to know how to set up DNS records. As long as you can get packets to resolve to to use that particular DNS name and resolve to the cluster, your packets will arrive and you can do your demultiplexing and termination there at the cluster. The other approach we're sort of using is a cluster IP route, which is sort of advanced, I suppose. It involves people adding, or for most of our customers, they sort of find it advanced because it involves, you need to have access to the actual router or load balancer to add static routes. That's sort of something that we've looked into. If you're looking at that little ingress chart, I just kind of put together like a couple of different things that we look at when we're evaluating like ingress setups. I think the first two that sort of jump out was on AWS and Google Cloud, they come with these integrated like ingress controllers. Those will actually go out and set up like an ELB or a Google Cloud load balancer for you. It's a little bit clever because they will set one up for every single service, which charges you a lot of money. We don't do that anymore. It's brilliant on their part, but even on AWS, we don't do this. That integration is enabled for people who want to throw money at the problem, but you can just run. The whole point of a virtualized representation of this is to run as many replicas of ingress as you need for whatever your needs are, and then do that all through one point. So that's where I have the cost in there. And so generally, for my personal clusters, I turn those off and then deploy an ingress controller similar to what Tectonic does. And then among those, you can pick host port, node port, cluster IP. And we've found that the right solution depends on your platform a lot. And up at the top, you can see on bare metal, you can do all three of those, and they have their own pros and cons. So.
All right, cool. Thanks for this chart. It's interesting. I will include it in the notes. I was just actually trying to do the same the same comparison, but didn't have time.
Yeah, if you have the capability, I personally run the cluster IP one, which is basically you just run the service, it gets a cluster IP, and use static routes or BGP to actually do routing to that. You have to have some external net translation. But
the cluster IP is so then you need to control what IP is assigned, right? Because it needs to be.
Yes, you fix that one IP.
Yeah, it's interesting, but I'm not sure if this is like the best UX. I would say that's advanced, right?
Oh, that is advanced. That's why. Yeah, that's not the one we commonly use in Tectonic because it's too hard for people to set up. But that's the one I personally use.
Yeah, at one client we've done some stuff with Calico and BGP, and then doing a separate route reflector that automatically updates be able to do that routing to services without needing the ingress controller. You can do directly to the cluster IPs with a routable, with a routable IP, as long as the space is routable within your infrastructure.
Yeah, I think we have the same approach. We wrote this external IP controller, which works. I think when it was written, it was intended to be used with Calico, and it essentially does the same, right? NJ, are you at the call to give some more details about the external IP?
Yeah, I am. Yeah, I'm pretty sure that this is like more or less the same approach that was like just described, because I just pasted the link to the charts and the description of this ECMP load balancing stuff that we did with this Calico and separate load reflectors. Yeah, so I'm pretty sure that this is the same as was described right now. So also our external IP controller also has this different operation mode, right? But this is probably like, let's say, too simple for bare metal probably.
Yeah. Okay, there's also the node port way, hacky, but who can describe that?
The node port is what we use on AWS because it integrates cleanly with ELBs.
So why hacky?
Well, it's just not external IP, and you can't have overlap.
Oh, right.
Like, say you have two services.
Okay, that you need to remember.
It requires a little more massage.
All right. So, is there any sort of pluggable global load balancer so you can actually have something else managing the external access, similarly to cloud platforms? Is there any sort of integration for that? there's this, for example, the external DNS that essentially integrates with external providers for DNS. Maybe there's something similar for load balancers. Probably not. Something to explore.
This isn't something we've really been looking into at CoreOS. The sort of approach has been thinking that get packets to the Kubernetes cluster, demultiplex at the cluster, rather than like designs that have a load balancer that is constantly notified of those changes. But probably other people have other opinions and might be more interested in that.
All right. I think it would be because we're still collecting some content or information to create the on-premise Kubernetes on-premise guide. I think it would be great to use this chart from Dalton. So I hope, Dalton, you're okay with kind of including this in the future. So
sure, we should have a more detailed write-up about this soon.
Yeah, Jorge, did you manage to get Marco on the call to talk about how you guys are doing this?
No, but I got Chuck.
You got a
Hello,
what?
can you hear me? Jump in.
Yeah.
Yep.
All right, fantastic. So the way that we're doing ingress is it really depends on the type of service resource that you declare. If you're declaring actual ingress resources, it's just using the ingress controller, very much like Dalton's diagram, where it's just binding a DNS mapping to a reverse pod lookup. Now, if you're doing something a little more advanced like node port, then at that point, it's up to you as the implementer. We're not routing that through a load balancer. That's just going to be on a node port on the unit. We're not integrating with any external load balancers at this time. Mostly because that's cloud specific, and we modeled with a bare metal first approach, right? So we were talking and riffing about how we could do this with like an HA proxy front end and just a watcher on the API to set up those mappings, but that's not something that we've done today. So that's future facing work that we haven't actually implemented.
Okay, that's cool. Thanks.
And no problem. I hope that was sufficient enough or in-depth enough. If there's any specific questions, I'm happy to answer those.
Yeah. Well, it's just for kind of, collecting the information at this stage. We plan to do some more thorough guide. We're also doing these demos just to see, what people are doing on premise. Okay, I think because we're running out of time. So Joe, do you want to conclude the demo? Some final words.
Yeah, you're gonna have to take it on faith that it works. My backend 00 is designated as master. It tends to take a little longer time to boot up as a result of that. So it'll be up probably in about 3 minutes. But it'll work. Honest.
Yeah,
I'm glad you did it on bare metal, because even though it's slower, a lot of people have just been reverting to showing things on AWS. So I appreciate that you're actually showing real hardware.
Yeah, I should have started at the beginning, but then I end up cutting off a little too much of the background information. You know what I mean? So
yeah, just another.
Yeah,
that bare metal is hard. And it's hard to.
I will reinstall. The thing about it is that it allows me to iterate a lot, because I will reinstall and uninstall and reinstall this cluster anywhere between 15 and 20 times in a day testing. Mm-hmm. So, just from my own development process on bare metal, this is awesome. And I frequently use VirtualBox as a front end to make sure I have a clean environment for the palettes and things that I'm testing. And being able to do that into bare metal is really pretty cool.
All right, thanks. Okay, I think we need to finish.
And Tomas, I'm sorry. I'll answer the questions that have been listed in the document. All
right, I can send the list, and you can answer on the mailing list.
Okay.
But you can also put it in the document.
Cool.
That's not a problem. All right, thank you very much. Any questions? Anything more? Probably not. Okay, then thank you guys. See you in 2 weeks. Well, actually 2 weeks will be KubeCon, right? Okay, we need to decide if we're going to hold the meeting or not. Yeah, it will be a KubeCon, so we might not meet in 2 weeks. We'll see. Anyway, we'll see each other live. That's much better. All right, thank you, everyone. So see you whenever the next meeting will be planned. Bye.
Yeah, I'm sorry.
Bye bye.
Yeah.
Thanks for the demo.